Hello, it's Eric again. My 250cc Puch engine rebuild is progressing. Last week we talked about installing bearings in the crankcase. Today we're going to talk about installing the crank and setting Endplay. Alright, we got our crankcase here featured in the last video. We installed the bearing. Right now we're going to take a couple measurements on this. Now the other half of this bearing is the inner race. We're going to go ahead and drop this in here. Like that. Now, I've made a tool here. It's a 12-inch long piece of precision ground bar stock. It's 12 inches long by 1 inch by ½ inch. I've drilled a hole in the middle to allow my depth gauge to go through. So now we're going to take measurement here with our depth gauge. We're going to go to the inner race and we're going to measure the relationship of the inner race with the crankcase split line. We're going to call this our inside zero play measurement. Next, we're going to flip this over. We're going to take another measurement. A little spacer there to hold it in so it doesn't fall out. Wood blocks here, shim it up. And now we're going to do the same thing, but on the outside. We're going to use our little gauge here. And we're going to take the depth mic and we're going to drop through this hole again. We're going to go down and we're going to measure the outside of the inner race in relationship to this nice machine surface right here. And we're going to call this our outside zero play measurement. All right, now we're going to take that inner race that we just used to take our measurement. We're going to install it on the crank. Now when I took this off, originally the factory had placed 2 shims underneath this race. So we're going to go ahead and we're going to put this back together with those 2 shims because I imagine it's going to be pretty close to what the original factory setting was. Next, we're going to add a little tool that I made here. This is going to help support the crank because we might have to tap on this race a little bit. And all it is, it's just a bolt and a nut that I've taken and you put it in here opposite your crank pin. Slide that in there and this is going to help take some stress off of this crank pin. We may have to tap this race on a little bit. You take this little bolt right here, we'll hold this end. We're going to kind of use it like a little jack. We're going to snug that up in there to kind of help stabilize the side of our crank. Next, I'm going to chill this crank down in the freezer to shrink it down, and we're going to warm up this bearing race a little bit, something similar to what we did with the engine case. All right, well, my crank's in the freezer. We're going to gently heat this bearing race with a heat gun. I'm not using the plumber's torch on this one because this is much smaller. It's going to heat up much more rapidly. The plumber's torch, I think it's a little too harsh for this. We don't want to overheat it and mess with the heat treat in our bearing. Also, I want to point out I've got a little driver here I like to use. You never want to hammer on this bearing directly in case you need to tap it on. Alright, I just got my crank out of the freezer, got my shims in place, and hopefully this bearing race will drop right on here, just like that. Make sure it's seated. Now we're going to let the temperature equalize. Now we're going to talk about the left-hand bearing. I've already installed the left-hand bearing in the left engine case. It's a similar method to the right I did with the right engine case. We chilled the bearing down and warmed up the engine case with a plumber's torch, and it dropped right in. And this is the unusual thing about this engine. Not only is this bearing an interference fit in the case, it's also an interference fit on the crankshaft. This is why we can't use a traditional Endplay check on this crank, because this crank is captive in the bearing. If we did an Endplay check with a dial indicator, it would only give us the slack in this bearing. it would not give us a true measurement of the end play in relationship to the right-hand bearing. So, again, I'm going to throw my crank in the freezer. I still got my little bolt in here to support it. We might have to tap this on. And I'm going to gently warm up this bearing and case. Okay, I just pulled my crank out of the freezer. I've been heating my engine case with a plumber's torch. This is a much larger piece of metal, so I had to use the plumber's torch to heat it up. Aluminum tends to dissipate heat pretty rapidly. This would have taken quite a while with the heat gun. So hopefully, we should just flip this over. And it should slip right on to the crank. Just like that. Now we're going to let the temperatures equalize, and we're going to put these case halves together, and we're going to take another measurement and see what our crank end play is. So, crankcase temperatures equalized. I flipped it over. I've installed the dowel pins here, and now we're getting ready to take our final measurement. But first, I want to kind of explain what I'm doing here. The manual that comes with this motorcycle is a little vague and doesn't explain very well how to perform this measurement. They reference a gauge that nobody has and can't be sourced anymore, and they kind of bounce back and forth between the metric system and the imperial system. You know, they give you the measurement in metric, but then they give you the tolerance in the imperial system, and it's kind of hard to understand. But basically, what we're doing is we're going to measure from the split flange to, there's a machine surface here right before you get to the shaft that this bearing sits on. And there's a measurement here, it's about 35.5 millimeters, plus or minus 1/10 of a millimeter. So how we're going to do that, we're going to flip this case over here. I'm going to drop this down on here. The pins all lined up. Seated down, no gasket. The manual specifies not to make this measurement with a gasket. Put some bolts in here, kind of secure it. All right, now we're going to take our final measurement. We're going to get this nifty tool I made here. I'm going to lay this across. Because this crankshaft sticks up too high, I can't use my hole anymore. But this works just fine. Set the depth mic and just go off the edge of it. And again, we'll take a measurement down to the outside edge of the inside race, and we'll record that measurement. We're going to call this the outside lash measurement for reference. All right, so let's talk about how you calculate the end play. We're going to start out here with the tolerance. Book states 35.5 millimeter plus or minus 1/10 of a millimeter. This translates to 1.394 to 1.402 of an inch. You come down here, first thing we're going to do is we're going to subtract our tool thickness out of our inside zero play. So I got a measurement of 1.918 for my inside zero play measurement, and the tool thickness is 0.502. So we subtract 0.502 from 1.918, which gives us 1.416. Now we're going to take our outside lash measurement, which is 1.665, and we're going to subtract our outside zero play measurement, which is 1.649. It's going to give us a difference of 0.016. We're going to take that difference of 0.016 and we're going to subtract it from our inside zero plate measurement that was calculated after we removed the tool thickness. So we're going to subtract 0.016 from 1.416 to give us 1.400. That puts us within our tolerance of 1.394 to 1.402. So this crankshaft is properly shimmed. I'd like to thank you for watching my video today on installing a crank and setting crank Endplay on a Puch 250cc split single engine. If you have any questions, feel free to message me or leave us something in the comments. Thank you.